Well, hello everyone. This is my presentation of basics of differential amplifier and operational amplifier. Myself, Dr. Sanjay Sharma, Department of ECE, ADGIPS, New Delhi. Well, this is the basic circuit representing the differential amplifier. We are having two BJTs Q1, Q2, their emitter being coupled, and the signals are being applied at the base of the Q1 and Q2. The important thing is the Q1, Q2 are matched transistors so that the output is not affected by the devices, and thus the output is the difference of the signal being applied at the base of the two transistors Q1 and Q2. This is the DC analysis, and this we set the V1 and V2 equals to 0, and then my Qcent points are being calculated, and that Qcent points are being mentioned as this, that is my ICQ and my VCQ. This is the Q point operation determination is important because it actually uh, lets our devices operational area characterize where we'll be working with our device that is being mentioned or demarcated by the operating point. Next is the AC analysis. In AC analysis, we set the DC voltages that equals to 0, and by small signal T equivalent analysis, we perform our AC analysis. And the equations that this is the circuit we are having for AC analysis, and uh, these are the things that we'll be calculating out, like gain, input impedance. Important is the CMRR, that is the common mode rejection ratio. It is given as the GM times RE. So GM being the property of the transistor being the constant, RE is actually a varying thing. So we want if CMRR to be infinite, we want RE to be infinite. But being a passive element, we want it to be replaced by a better active element. So in the next slide, we have used a current mirror circuit for the improvement of RE, and we have used this transistor, that is Q3, uh, for providing the constant current to the Q1 and Q2 transistors. In this, we have utilized the resistances and the diode. The resistances are being utilized to provide the necessary biasing, and diode is being utilized to provide the temperature insensitiveness to the signals. This is the improvement in the circuit. In this, we have removed all the resistances, and we have tried to match the I reference with the I output by using the two back base connected BJTs. The base of Q1 is shorted with the collector of the Q1 so as to make it a switch like arrangement, and thus driving out the Q2 and making I reference equal to I naught or I 0. This is the block diagram for operational amplifier, and I hope we can clearly see that two inputs are there V1 and V2 with the differential amplifier stages plus the buffer and the lever translator and the output driver. So my crux is that the differential amplifier is the key component of an operational amplifier. So that we have discussed in the previous slides. This is the schematic symbol of the operational amplifier. We are having two input available, like inverting and non-inverting terminals, and an output terminal plus our power supplies. This is the 8-pin description of an operational amplifier. Fire. That is my inverting terminals, non-inverting terminal, the output, the VCC or the power supplies. We are marked in it. These are the characteristic of an ideal operational amplifier. Like infinite input impedance, we want it so as to have the minimum loading effect of the previous stage. Zero output impedance or the infinite CMRR. Infinite CMRR is required because we want the differential gain to be maximum, but at the same time the common mode gain to be minimum, so that our noise is cancelled out. Infinite loop gain, infinite bandwidth, and lastly the infinite slew rate. The infinite slew rate correspond to the faster switching or the faster response of my circuit to the input signal. Now this is the schematic symbol and the subsequent transfer characteristic curve. As we can see in the transfer characteristic curve, that the signal saturates after the power supply voltage. Suppose we have given a 15 volt of power supply, we cannot have more differential output than this power supply. That means if we have given a power supply of 15 volts, we cannot have more than 15 volt of differential signal. So this is the most important thing in the transfer characteristic curve, and this is the op-amp realization using BJT and justifying the block diagram. That is, we are having two differential stages, differential stage 1, 2, lever translator and emitter follower circuit. So in all, we can see that how many BJTs are employed to make out one operational amplifier. Thank you very much. Your queries are welcome. Thank you.